In the next section, I'm going to talk about why is random number generation important in gaming. Actually, random number generation is also very important in security, but today I will specifically talking about application in gaming. You might recall that in my last talk, I talked about Metaverse security and give a brief overview of the 7 layers of the Metaverse. To refresh your brains, the conceptual framework of the Metaverse consists of 7 layers. The first layer is what consumer will be experiencing and goes all the way to the backbone of the Metaverse, such as service and equipment providers. Today I will be diving deeper into how PUF-based technology can apply to the experience layer of the Metaverse, in particular, the role of random number generation in gaming. Okay. Please turn to page 14. Okay, random number generator, abbreviation is RNG, are algorithms or hardware components that create random values. In gaming, random numbers determine random events, such as your chances of picking up a rare item or even which shape of a block you get on Tetris. Video games obtain their variables from naturally changing local values. For example, a game console's internal clock or the sequence of buttons you pressed. Sometimes these numbers are easy to hack, especially for seasoned gamers. Please turn to page 15. And using role-playing games, abbreviation is RPG, as an example, players typically complete missions by slaying monsters, challenging bosses, and acquiring powerful items. As you play through the game, the monsters you kill will randomly drop new equipment, where it can then be looted. Every item has a quality level. For simplification purposes, we will talk about the common items and the legendary items. When the monster drops an item, the game randomly determines its quality, with chances for a legendary item being extremely low. In mobile RPGs, while the game is free to play, microtransaction option allow gamers to buy in-game items that supposedly guarantee certain weapon drops. The drive to acquire better items keep people addicted to games and spending a lot of money. Okay, please turn to page 16. About the software versus hardware random number. So in software random numbers, when developing computer games, programmers usually use seeded software-based random numbers, which use a seed number to create their numbers through a mathematical algorithm. Each time a new number is generated, it is built upon the seed number and the past values, resulting in a sequence of random numbers. However, the seemingly random output sequence is deterministic because the seed is a fixed number, so the sequence is reproducible. A good real-life example is programmers who use a certain logic or patterns to determine random numbers. Typically, software-based random numbers are good enough for and often used in games to offset players' chances and keep the game exciting. In the role-playing game example's case, the random number will determine the weapon revealed during a drop or microtransaction purchase. And about hardware-based random number generator, I previously mentioned that computers need the physical world's randomness to generate true random number. A good real-life example is leaves that fall from a tree. The location where the leaves land will be truly random and unpredictable. Similarly, silicon devices themselves generate noises that are random in nature. While those noises are smaller, we can design circuits to amplify or accumulate these noises. Then we can digitize the analog noise signal into digital random numbers. Please turn to page 17. So while software-based random numbers keep game unpredictable and fresh, they are criticized for their lack of true randomness. A computer cannot just put out a random number as easily as rolling a dice, which is why today's gaming world often uses software-based random number generators, because not all system performs have entropy harvested from the physical world. Moreover, if the random numbers are generated with a specific platform, they could potentially be controlled, compromising the fairness of the random numbers. Because of this, many question if in-game purchases guarantee anything. Many players spend thousands of dollars on in-game purchases, and certain microtransactions have been compared to a gambling simulator, leading to controversies in the gaming industry. Some countries have even banned certain games since it violates anti-gambling law, as seen in these articles. In fact, Taiwan's Ministry of Economic Affairs recently announced that they will require game companies to disclose their odds of winning in the face of these unfair game practices. Thus, replacing software-based random number with true hardware random number is an inevitable trend to create a gaming ecosystem with better fairness. Please turn to page 18. What does the true random numbers affect the game industry? First of all, let's look at about the player. From the player's perspective, whether it's an RPG or speed game or gambling game, etc., credibility is important. Players want assurance that there's some form of fairness in their games. Many people go so far as to look at the data and the percentages around games to determine if the results they are getting and the money they are spending will have a fair outcome. And for the game providers, it is vital to have a verifiable, quantifiable RNG that provides necessary transparency to players. And about the digital asset, perhaps an overlooked aspect is the potential item purchased in these games. As the world transforms, items used and purchased in game, such as the weapon we mentioned in RPG games, can evolve to NFT. With the involvement of the virtual assets, the credibility of NFTs have become more important than ever. Assets need to be traceable from their origin to determine their authenticity. Furthermore, NFT also require security protections. Okay, so please turn to page 19. So how do you generate those random numbers, and how do you protect the assets? With our PUF-based TRNG, this becomes possible because it uses an on-chip physical entropy source to produce secure and systematical numbers. Generating random numbers on the blockchain decentralizes the process of generating random numbers from the providers to the third party, bringing more transparency, fairness, verifiability, and the temporal resistance to the random number generation process. Since gameplay requires massive data and is played by numerous players worldwide, many random numbers are needed. implementing PUFtrng on blockchain nodes will produce enough random numbers on the chain to accommodate the volume of random numbers required. The game servers will request random number from the blockchain nodes, which operate in games. Once produced, the random number will be uploaded to the blockchain. Since blockchain is an open database, it maintains a public record of the random number used in gaming. Given this record, everyone can check the random number used in each microtransaction to verify whether the random result is fair or not. So the application of our PUFtrng can further extend to creating secure private keys that encrypt online data, and the PUF-based OTP can even store these secret keys. As a result, every time a transaction takes place, such as sending cryptocurrency, the key pair can be used to secure your transactions. Security is critical in the future when game-based transactions promote the exchange of NFTs and other valuable assets. Our PUF-based security solution can be easily and widely used in gaming applications, which is an important part in the experience layer of the Metaverse. Okay, this concludes my presentation on this random number generations. Thank you.
Thank you, Charles.